Code it now. So for this first activity, we're going to compute the following sum. Sum the even numbers from A to B. Okay, so this sounds very similar to a code it now activity that we've done in the past where we had to sum the numbers from 2 to 20. The difference here is that we might not necessarily know what the range is. We're going to have A and we're going to have B. So we need to change our code up a little bit to accommodate for this. Okay, so let's go over to the JGrass window, create a new file with Control-N, enter to accept the default Java. Then we can go back to one of our old files, so for example, SumEvens, which is the one that it's going to be very similar to, so Control-C, then back to our Untitled window, and Control-V to paste. So for this one, it's going to be similar, but we don't want to give it the same name. We want to give our classes different names. So let's call this one SumEvensAB. Simple enough. Just going to add a little bit to the end. Okay. So we also want to change our comment. We don't want to keep this because we don't know if it's going to be 2 to 20. It's going to be from A to B. Oh, to B. There we go. So of course, we're still going to want to have our sum start at 0, so that's fine. And then the next thing we're going to want to do is define A and B. So we're just going to define arbitrary values for A and B, but obviously it shouldn't matter what value we define. It should work regardless. So I'm going to put A equals, let's say, 4, and B equals, let's say, 30. Okay. So now, since we're not hard coding our values anymore, we're not just assuming it's going to be from 2 to 20, instead it's going to be from A to B, we accordingly want to change where our for loop starts looping and where it ends looping. So we no longer want to start at 2, we want to say int I equals A, and we no longer want to stop at 20, we want to stop wherever B is. So, as long as I is less than or equal to B. Now, it may be really tempting to use I plus equals 2 here. But here's the problem. We can't just do this because we don't know where A starts from. A could possibly start from an odd number. So let's say A starts from 5, right? So then if we imagine as we're going along, we start at 5, we increment by 2, now we're at 7. And the code we have right here, it would add 7 to the sum, but we don't want that. We only want to sum the even numbers from A to B. So that means we're going to have to change the way we think about this. So we no longer need this. Oh, whoops, wrong thing. What I meant to say is we no longer need this. Instead, we're just going to replace it with an I++, because what we're going to want to do is we're going to want to go through every number between A and B one by one and check if it's an even number. And if we know that that number is even, we'll add it to the sum. So as what I just said sort of implies, we're going to be using an if statement. So let's indent, let's add our if statement, and now let's think about this. So we want to check if a number is even. So how do we know if a number is even? A number is even if when we divide it by 2, it has no remainder, because that means 2 goes into it evenly. So what we can do here is we can say if I, and then modulus, or the percent symbol, which is the operator for finding the remainder, 2, right? So if I modulus 2 equals, and remember we have to use the double equal sign for checking equality. If this equals 0, then we want to perform our sum. So let's add in our curly braces, and let's also indent the sum here. Put our closing curly brace. And there we go. And if you just want to be extra sure that you don't mix up any of your code, we can put extra parentheses around this statement so it's very clear what we're doing. We first want to perform this remainder operation, and then we want to check if the result of that is equal to 0. And that's how we know that a number is even. So some additional comments we might want to write. Maybe we could add a comment right here to explain why we're using this remainder operator. So we can say a number is even if when divided by 2, it has no remainder. So that way someone reading our code understands, oh, okay, I see why they're doing this with I. They want to check if it's an even number, and if it is, then they end up adding it to the sum. Okay, and the last thing we're going to want to change is this print statement here, because although we still are adding the even numbers, we're doing it from A to B instead of from 2 to 20. All right, and yeah, that should be everything that we need to change. Another nice thing to do actually might be to change the value of A to an odd number to make sure that our code isn't adding odd numbers, because if it was adding odd numbers, then we might get an odd result. So let's check that by making one of the values A or B an odd one. So we'll make it 5. So let's save this, Control S, Enter to accept the defaults, Control B to compile. And that's great, it compiled successfully with no problems. Control R to run. And here we go. So the sum of the even numbers from A to B is 234. Okay, so now that generally sounds like it would be correct. And if we think about it, there's from 5 to 30, there's quite a few even numbers. So I think it makes sense. It's a reasonable result. I would say if this result was maybe 1,000, I'd be a little concerned, because 1,000 doesn't seem like it'd be quite right, but 234 seems like a pretty safe answer. And we could always, of course, look over our code again. So we're starting with a separate sum variable, which we definitely want to do. We have our two range variables, so A, B. We're starting from A, we're going all the way up to B, and we're only adding if the remainder of I divided by 2 is 0, which makes sense because that means it's even. So yeah, this seems right to me. Code it now. So now we're going to move on to activity number 2, because we already did number 1 in a previous video. So we want to compute the following product. So compute n factorial equals n times n minus 1 times n minus 2 all the way down to times 1. Okay, simple enough. So let's move over to our JGrass window, and let's create a new file with Control N, accept the default Java by pressing Enter. Let's go back to our previous file for a second, just so we can copy the code and we don't have to retype some of the stuff we're going to reuse. So Control C, go back to our untitled file, Control V. Okay. So now let's give this class a new name. The most logical name to give it is Factorial, since that's what we're going to be computing. Factorial. There we go. Okay, and in this case, I'm going to say that we should get rid of everything above the print statement, because we're definitely going to still want a print statement at the end. But everything else I'm going to get rid of, since it's going to change in a pretty substantial way, I would say. All right, so let's start the coding that we're going to do. So we want to compute factorial. So we should explain in the first comment what a factorial is. So we should just say compute the factorial of n, which is n times, we can save a little bit of space and do it like this, n times n minus 1 times n minus 2, and then we can just add little dot 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 times 1. Okay, let's put a new line. All right, so now we have to think what variables we're going to need. So in this case, we're not summing, we're multiplying. So we're going to have a product variable, and we could just call this variable product. So let's just start with that. And product equals. Now, normally when we do a sum, we start from 0. But in this case, since we're doing a product, we can't start from 0, because if we started from 0, that means that each time we multiply, we'd just be multiplying by 0, and obviously we wouldn't get a bigger number. Obviously, our result wouldn't depend on what the value of n is, because since we're starting with 0, we're always just going to get 0. So we want to start with 1. And then, of course, a semicolon. And then the other variable we need is n. So in this problem, we're not told to accept user input, so we're just going to code in a value for n manually. So int n equals, And we can just choose any value. Let's choose a simple value like 6, let's say. Okay. So now that we've done that, we can go on to the actual for loop. Okay, so for int I equals, so now we want to think of where we should start from. So in this case, we can actually just go ahead and start from 1 if we want, because we're going to start from 1, so 1 times 1 is 1, and then from there onwards we can go on to multiplying by 2 and 3 and 4 and all the way up to n. So we can say I equals 1, as long as I is less than or equal to n, and then I plus plus, because we want to increment step by 1, because we want to multiply 1 by every number between 1 and n. So we want to go 1 by 1. That's why we can just use that increment operation. And make sure you indent, and of course don't forget your curly braces. And what we want to do is we want to take the product and we want to do a times equal I, and of course semicolon. And obviously the reason we're doing times equal is because we want to multiply, and we want to store that back into the product variable where we're keeping track of what this result is. Okay, that looks good. And keep in mind here as well that the way we coded this, we ended up sort of doing it a little bit backwards. Because if you notice, the way the factorial is defined in our problem is that we start from the highest value, n, and we go down 1 by 1 by 1 until we get to 1. But the way we coded it, we started from 1 and went up to n. And this doesn't really matter because obviously multiplication is associative, meaning you can flip around the order of the multiplication and the result will still be the same. So keep that. So that's very important to notice that, we're still doing the same operation. And the reason I chose to do it from the beginning of 1 all the way up to n is just because we've been working with a lot of for loops in the past files, and we've done it in this way where we started from the 1 and then went up to whatever number we need to go up to, like 120, n, b, whatever it may be. So it just seemed natural to do it this way. Okay, and I don't really think we need any more comments, but of course we do need to change what we're printing out. So print out the results of the factorial, we'll say, and change our text here to read out the factorial of n is. Of course, we need to have our space after the is. And instead of sum, we're going to print out the product. Great. Okay, so now we can save our file with Control S, accept the defaults with Enter, Control B to compile, and great, we had no issues while compiling, and then Control R to run. Okay, and we got that the factorial of n is 720. So this result makes a lot of sense because factorial of 6 is a pretty easy one to compute because 6 isn't too big of a number. That's sort of why I chose it, because I want to choose something where I more or less know what the result is going to end up being, so we know that our code is correct. Because 6 times 5 is 30, and then 30 times 4, or rather, let's think about the other way actually. Let's think about it the way our code is going through it. So we start from 1, so 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 24, right? And then 24 times 5, 24 times 5 is 120, and then 120 times 6 is 720. So we know that our code worked correctly.